think you have to click continue in order to consent to the recording. But thank you everyone for coming. We're going to begin, and then I think a few more people might end up trickling in. I'm going to hop out of the French interpretation room because otherwise I think I will end up hearing at the same time. But are you ready to go? Okay, so I'm going to jump out of the French interpretation room and I guess you can begin interpreting. Wonderful. But before we begin, I guess I should say in French, nos amis francophones, nous avons d'interprétation en français. Notre collègue Arthur fait l'interprétation dans une autre salle de la vidéoconférence. Et voici les instructions. Il devrait y avoir un bouton là-bas avec le symbole d'un monde. Arthur est dans la salle de français, French. Et vous avez l'option de couper le son des orateurs anglophones ou d'écouter les deux en même temps. Donc, est-ce que la fonction marche ou pas, nos amis francophones? Est-ce que vous...
moi, je ne vois pas le symbole. Hein.
Okay.
Même moi, je ne vois pas.
Est-ce que vous avez l'application de Zoom ou est-ce que vous êtes dans un Chrome? Je pense que c'est nécessaire d'avoir l'application.
Oui, j'ai Zoom installé, oui. Installé dans ma machine.
C'est la même chose chez moi, j'ai Zoom qui est installé. Bon, ceci dit, je peux aller en anglais, il n'y a pas de souci, mais bon, s'il y a le français, je préférerais. Sinon, j'ai l'application installée, mais je n'ai pas le bouton.
Vous ne voyez pas le bouton. Alors, attendez. Vous voyez mon ordinateur, mon écran?
Oui, Pierre, on voit ton écran.
Voilà, je vais essayer de vous montrer comment ça marche chez moi. Ah ouais, mais non, je ne peux pas. Malheureusement, je ne peux pas, bien sûr. Parce que je partage mon écran, donc je ne peux pas vous montrer l'application. Mais c'est vraiment en fait ce bouton d'interprétation qui est en bas. Peut-être essayer de rejoindre sur la version en ligne. Je pense que la version en ligne, vous devriez le voir.
D'accord.
OK.
Dans ce cas, vous pouvez laisser le lien de la version en ligne sur le chat.
Okay. Can you do that, Grace?
Yeah, I'm searching. Just for our English speakers, we're just trying to troubleshoot the interpretation in French. So if you...
J'ai vu, hein, chez moi, c'est bon là.
Ah bon?
C'est bon?
C'est arrivé. Interprétation.
OK.
Bon, je vais actualiser chez moi, voir.
C'est sur la barre en bas là. Sur la barre où il y a partagé écran, enregistré, interprétation, réaction.
Non, j'ai juste réaction, j'ai pas interprétation. Peut-être.
Ah, bon, ben chez moi, c'est bon. Donc, je clique sur français.
Arthur, can you interpret what I'm saying now to make sure Michel can hear you?
Okay.
Michel, is it good? I don't hear Arthur because I'm not in that room. Can you hear him, Michel?
Oui.
Okay.
Oui, je t'entends très bien.
Okay.
Okay, perfect. So let's start and peut-être Fofana essaye de voir, mais on va démarrer parce qu'il y a déjà du monde. Okay, let's go.
Okay. All right. Well, welcome everyone. Thanks so much for joining us today and on a Saturday. Today, if you didn't know, is the annual Open Data Day. This is where groups from around the world meet together and encourage the adoption of open data policies. And also meeting their local communities and talking about the importance of open data. So we're very glad that you've chosen us as your 2 p.m. GMT slot. We are the Labs and OpenDRI team of the Global Facility for Disaster Reduction and Recovery, or GFDRR. We're a part of the World Bank that focuses on disaster risk and how governments can use better risk information to protect their populations and to save lives. We're here today on this call to talk about open data for disaster risk. I think we have a diverse audience on this call. Maybe you work with open data already for topics like transportation or biodiversity. Maybe you work in governance or disability access. But we're here to tell you that the data that you work with, the data that you are fighting to make open source, can support better disaster reduction and recovery efforts. So today on this call, we're going to begin by talking about the basic principles of this concept, disaster risk. And then we'd like to introduce you to a few important tools that we've been developing and using to understand and reduce disaster risks. So with that, I'm going to pass it over to Pierre Krasnowski, who is the lead for the OpenDRI team, who will speak with us in a bit more detail about what is disaster risk. Over to you, Pierre.
Yeah, perfect. Thanks a lot, Grace, and welcome everyone. It's a pleasure to have you today, and also my pleasure to wish you a very good Open Data Day. I think it's almost 10 years or 11 years of Open Data Day today, so it's good to see, that kind of community-based events to continue, and with still so many events around the world. And I'm hope from whenever you connect, you're safe and well, and wish you a good webinar. Okay, so let's start. And as a starter, I'm going to introduce you and run you through. We have a little short video on what we mean by disaster risk, actually. And so I'm going to run that video. It's quite short, it's 2-minute video, and then I will explain to you some of the key concepts and elements of what is exactly disaster risk and how to work with disaster risk data. So let's try. Okay, so
impacts from natural disasters are on the rise. Around the world, hurricanes, droughts, floods, cyclones, earthquakes, and volcanic eruptions pose a growing threat to economies and the lives of millions. Global disaster losses have risen sharply from over the last few decades, totaling $4.2 trillion since 1980. Moreover, the poor are suffering the most. Over the last 20 years, low-income countries experienced just over a quarter of flood events, but suffered nearly 90% of related casualties. Investments in preparedness and resilience can keep these natural hazards from becoming human catastrophes. With drivers like rapid urbanization and climate change, however, disaster risk is evolving rapidly in today's world. To know where and how to make investments before a disaster strikes, we need to be able to identify risks rapidly, rigorously, and regularly. From individuals and communities to governments and businesses, understanding disaster risk is everyone's business. And with technology making the tools and information more accessible than ever, people all over the planet are pitching in. Citizens in Nepal are crowdsourcing more accurate maps of their neighborhoods using open data. Universities from around the world are collaborating on multilingual films to spread awareness of volcanic risk to communities in the East Caribbean and the Pacific. Government agencies are even using social media to better understand flood patterns in the Philippines. In today's world, you don't have to be a disaster expert to make a difference. Whether you are a scientist, a politician, or a concerned citizen, we can all help better understand our risk and make steps toward lasting resilience. What will you do? To learn more, visit gfdrr.org/risk www.labs.OpenDRI.org/innovation-lab.
All right, so I hope you could see and listen. Maybe the French subtitles were a bit, but I hope it was okay. So let me get back to the presentation. Okay, so now I'm going. So now you saw that short video about, I mean, what is disaster risk. I hope you understand that there is a difference between speaking about an hazard and speaking about a disaster, and also speaking about the risk of that disaster. So I think it's important to understand those different concepts and to understand the kind of data that are related to each of those. So I'm going to start with the actual definition of what is disaster risk. It's provided by the United Nations Office for Disaster Risk Reduction, UNDRR, and they define disaster risk by the potential loss of life, injury, or destroyed or damaged assets, such as, for instance, buildings and any infrastructure. So as a function of hazard, exposure, vulnerability, and capacity. So when you want to understand disaster risk, you need to understand all those different elements and to combine them together. So I just wanted to provide you this definition, because it's the baseline of really our work and the baseline of what we mean by disaster risk management, for instance. So who works on disaster risk? Well, actually, lots of persons, I would say, at both global level and also local ones. So at global level, you have GFDRR, us, Global Facility for Disaster Risk Reduction. We are hosted by the World Bank. You have also the United Nations with the office like UNDRR and so on. And also disasters, of course, disaster reduction, disasters activities are closely related to humanitarian activities, because when a disaster strikes, you also have to respond quickly. So you also need a humanitarian assistance. So maybe a first distinction between humanitarian activities and disaster reduction activities is that disaster is more on the, let's say, the long-term preparedness planning, but also recovery phase, whereas humanitarian and the response, it's part of disaster risk activities, but it's more focused on helping people where really they are in urgent needs of support. And again, so it's really a global effort with lots of local governments, experts, also organizations such as civil protections that are working on the ground. But also you, I think something very important is that the first concern and the first able to act in the case of a disaster are the people that are exposed and affected by those disasters. And in a way, open data is bringing you new possibilities to learn, understand, and react or prepare to disasters. So now, what we are talking when we are talking about risk data or disaster risk data, and also why we would like those data to be open. So I think first on open data and the concept of open data, I think it's not new for anyone here, but it's still important to remind ourselves that open data is this idea of having data that you can reuse for any purpose, that are accessible online. And so you have no restriction attached, right? So, and this is important not only for people who do research or who work on to develop a specific application, but it's also very important for collaboration and also communication. So actually any activities that require collaboration between people require information to be shared. And I think the principle of open data is at the core of that collaborations activities, and therefore it is also at the core of disaster risk, because disaster risk is first about collaboration. So then when we look at the different type of data, so we actually have a lot of different data types, and the first one, of course, is data about hazards. So hazards, historical hazards such as a volcano, an earthquake, a flood, but also future. So the ability to do projections and anticipate the future hazards. And it's not something that is easy, because hazards are by nature probabilistic events, and it's very difficult to predict. So we have the science of behind hazards to understand when next hazard could strike, but still it's still an area of research, and therefore it is important to have the most up-to-date and accurate data on hazard for a given area, but also on hazard for I would say globally, so that we can improve the comprehension, the understanding of hazard as a science. Then we have the data on, well, us, let's say, the people and their assets exposed to those hazards. So as you understand, when we are talking about disaster, is where an hazard occurs, where there are people living, and so that it is a disaster. And so this is very important to understand that, and also, and then it is important to collect the data on those people and those assets that are exposed to hazards. So that's why it's important to have, for instance, up-to-date census of population, but also up-to-date data, for instance, on building footprints. And then you have a very specific set of and type of data, which is vulnerability. So vulnerability is, let's say, the link between population or assets and their vulnerability to a specific hazard. So if you want to know the possibility, for instance, for a building to collapse in an event of an earthquake, you will need to know about the vulnerability of that specific building. And those are quite specific type of information, most often developed by researchers through risk models, and most often developed also by the insurance industry. And one of the difficulties to find that type of data, in particular in developing countries, where you don't have enough insurance activities, and therefore not enough data on vulnerability. Functions. And another one is information on the capacity. So capacity to react, but capacity also to prepare, the capacity to respond, to recover. So let's say those data are more about the institutions and the capacity of those institutions for a given country or city to prepare, prevent, and respond to a specific disaster. And this is also useful for you to understand the risk. And the last one, which I mean is new one, is climate change. We know that climate change is going to impact on many different types of hazards, and therefore it is important to understand not only the climate projections, but also their potential impact on those hazards. And therefore it's also important to continue to collect the data on the climate change, but also to collect or produce data on the link between climate change and hazards and disaster risk. All right, so that's really in a nutshell the different types of data that you may want to collect as open data, or that you may want to ask to your governments, national, local ones, and the type of data that you need to work and to better understand disaster risk. All right, so I'm going now to stop, and I will ask my colleague Mattia to continue and to show you what we can really do with disaster risk data. Thank you.
Thank you, Pierre. So how we can use the data we just presented to obtain a risk information. And next slide, please. So risk assessment is also referred as risk modeling and catastrophe modeling, and it aims to estimate the impact of events that may have happened in the past and haven't been recorded, or plausible events that have not yet occurred, so-called risk scenarios. And the objective is to understand where and when catastrophic events are more likely to happen in order to manage risk by planning adequate preparatory and response actions. Next, please. The customary framework for risk assessment combines exposure data, which describe, as Pierre said, the asset value and socioeconomic status, with the hazard data, which describe the intensity of a physical phenomena as a function of its probability of occurrence, which is often expressed in terms of return period. So the probability of occurrence, for example, of once in 100 years. This is done, the combination of these two elements is done using a vulnerability model that translates the information from the exposure and the other components into one estimate of potential losses, expressed as a share of the total exposed value. The losses are inversely proportional to the capacity to prepare, to mitigate, and to respond to the hazards, so the capacity element we've seen before, and then to compensate for part of the potential negative impacts. Next slide, please. The losses estimated over the economic, or for example, GDP, or the social value, for example, population, for each probabilistic scenario can then be combined into one single estimate of damage exceedance probability, which can be expressed on an annual scale, so-called average annual losses that represent the most common measure used to communicate risk and its change according to future scenarios. So in this framework, risk is expressed as a loss multiplied by the probability that it can occur. And this is the end of the short overview on the risk assessment approach. Next, please. Which methodologies were developed by GFDRR in order to better understand risk? There are a series of web application and tools that can be of use in order to better understand and depict risk data in reality. Next, please. The first one is Think Hazard. It is a public website hosted by GFDRR, where the spatial information produced at the global and at the local scale is harvested and assessed to produce one homogeneous ranking of combined probability and intensity of natural hazard within a country and within administrative units in a country, according to scenarios. There are 11 natural hazards covered by this tool, which is updated every time a new data set is released. It doesn't include the climate dimension at the moment, so climate indicators affecting hydrometeorological hazards are something that we are going to include in next version. The website is accessible by phone as well. Next, please. The hazard data featured in the Think Hazard application are hosted by the GFDRR GeoNode, which is an open platform which offers visualization of the spatial data and related metadata and access to public data for download. For the next tools, I will switch over to Grace.
Thank you, Matt. So where Think Hazard ranks hazards and GeoNode gives access to specific risk data, the OpenDRI index tracks the state of openness of all key data sets related to risk in a given country. So this is a crowdsourced initiative. You can go straight to the site and sign up and submit data sets. It allows researchers, governments, any users or interested parties to locate exposure and hazard and other risk data sets, and importantly, to rate their degree of openness. So as some of you may know, openness is not just a matter of, can I access the data set? Can I take it? Is it public? But there are other questions like, is it in a digital format? Is there contextual information like metadata provided? How old is it? You know, is a data set really useful if it's 20 years old? So anyone can go to the site and submit data for the country, for any country that, that you're interested in. So please do sign up. Next slide, please. And then Open Cities is a wonderful program that we manage, which gathers together members of the local community, municipal governments, and members of the tech space to collaboratively work together to collect map data on specifically and typically critical infrastructure, or as Pierre was describing, the exposure data sets. I think we have a few Open Cities colleagues on the call today. So thank you guys for joining. Open Cities is a methodology that's not just focused on collecting data, but also on building capacity, the capacity of youth and local institutions in geospatial technologies. So you can use an Open Cities style methodology in your area. We have a resource, a guide, which we'll provide to you at the end of this webinar. Next slide, please. Finally, we just wanted to speak a little on machine learning. Artificial intelligence and machine learning in the field of disaster risk is growing exponentially. And it's incredibly promising as a tool to accelerate data collection for broader coverage or to gain insights that humans just can't figure out as rapidly or in as much detail. But we also need to make sure that artificial intelligence is well understood by its users and by the people whose outcomes it's affecting. So that means making the process transparent and easily explainable. We have a few different resources on our site to help with the understanding of machine learning in the context of disaster risk management, including an upcoming paper, which we'll be publishing soon, on responsible AI and ethical artificial intelligence practices. So those are our tools. And now I think I'll be passing it back to Matt to show you one of our Python notebooks for analyzing risk.
Thank you, Grace. So in the end, finally, we want to mention these collaboratory notebooks, which are a great way, we think, to facilitate access to modeling of risk data, allowing to perform analysis over open data and produce usable outputs for analysis. They are based on open infrastructure and libraries that use Python language. They can be run on any browser without installing any utility program plugins, and they can be tailored to different purposes and data. We know that because the learning curve to understand how to code this analysis can be quite steep, the collaboratory notebook is fully commented, and the action required by the user can be reduced and simplified to the minimal choice of model and data option. We have one example that is offered at the link below, can be accessed and be run through for any user to appreciate. Depending if we have some time left, but I guess no, we can also run through one of these notebooks. Up to you, Pierre.
Yeah, I can try to show quickly. So here we are. It's fine. I just need to click on.
No, you don't need to execute it. We just can show through. So basically, this list of instruction can be executed by just personalizing, for example, the input data. You can go below. This part doesn't really need to be understood by the user. You can go down. For example, here you can choose to load your data, and we are also looking to make this even friendlier. So you just need to check for one line of code where your data set lies. And we also think to offer this loading of data through API, which is very convenient for the user. After we load the data, we can check the data that they are correct, they work as intended. So in this case, we load the flood data and population data for South Sudan, as shown in this map. So this is RP100 over South Sudan for a range from 0 to 2 meters of flood water. The first operation we can do is to just measure the flood area. So how much for each administrative unit is potentially prone to flood? Can you scroll down, please? And so we have a measure for each administrative unit, which is shown in the map. But this information is just preliminary, doesn't tell all the story. So we want to go and see where is the most amount of population that is located in flood-prone areas. So the next piece of code, down please, show the combination of the flood-prone areas for water depths higher than 15 centimeters, so which is a minimum threshold of hazard, and overlaid to the population layer provided by Landscan 2018. In this way, we can measure the total amount of population that reside within these flood-prone areas. And can go down, please. And summarize the information again at the level of administrative units, so even administrative 1 or administrative 2 shown below. And we can already see that this information is quite different from the simple analysis at step 1. And we can identify the administrative region where the bigger cities and the most population are located as the primary exposed to hazard. You can execute this, and also it will produce an output both in table and in form of shapefile that you can download in order to work offline with your favorite tools, or just use to produce your own maps. And that's it for this small example, but it has a huge potentiality to extend to many other functions and build complete analysis frameworks. Thank you.
Thank you, Matt. So I think that's all from us. So I hope it was useful. And as you can see, I mean, what we just described is really kind of what we call, a risk data pipeline. So from data collection activities that you want to define to the actual data management or data sharing through digital platforms, and to the actual deliverables. So a map, a table, any analytics that can be used for decision making or for communicating risk to a population. And something we think is important is, so we have all those tools, we have more and more open data. But what is important, if you have any, if you're considering working on this for your city or country, is to have a clear problem statement first. And it's always, okay, I want to work on flood, I want to work on that particular issue in my city, but what exactly you want to tackle? So that's something really pushing is to define clearly your problem statement so that it will help you to define also the type of data that you need to respond. So I think that on that note, I will stop and I will open to you, to the participants. So if you have any question, if you want to react, tell us about your city or country and the type of disasters you're facing and how you may want to work on that. So we are not so many, so we can also have an open conversation and have about, like, let's say 5 to 10 minutes to discuss. So thanks again, and please don't be shy.
Also, feel free to write in the chat if you are a bit shy.
May I maybe ask one of you to, I don't know what's the type of disasters you are facing on a regular basis. Do you have flood in your country or city? Do you have earthquakes? Do you have volcanoes? So it would be good to hear from you.
Hello everyone, can you hear me? Mickey
Yes,
speaking.
Go ahead, Mickey. Hello.
Hello. First of all, thank you for a beautiful and inspiring presentation. It was very nice. And if you are asking about our local regional problem, I'm based in Slovakia and east part of Slovakia. And I don't know English word, but it's a geological word. It's flish, and it means there is too much landslides. You know, there is not too stable the relief and the cover. I would like to ask you if you have some experiences with this, or if you counted with the hazard and so with floods. Thank you.
Yes.
No floods. Sorry.
Landslides.
Thank you.
Landslides, of course. So landslide is, one of the most deadliest disasters in the world, and particularly when it's occurring in cities. So we saw, a huge landslide, for instance, in Central America quite recently. There was a big one in Freetown, in Sierra Leone as well, just in the center of the city. And so, of course, it's something that we cover. Actually, on landslides, there is a global data set that you can reuse. And I may ask my colleague, Matt, to maybe just describe that.
Yeah, with the collaboration of Arup, which is a geological consultant, we produced a global hazard layer for landslide based on the NASA susceptibility layer previously produced. And this hazard layer considers both the earthquake trigger, so the landslide that are caused by ground mass movement, and the rainfall triggers, so intense precipitation that accumulates and then trigger landslide. And this is done separately from flooding. It's specifically just for ground mass movement. You can find it in our DDH, the one that has been shown by Pierre now. It's separated in 3 different layers, so earthquake trigger, rainfall trigger, both mean and median, and one aggregated layer that just communicate the level of hazard as think hazard does.
Yeah, thanks a lot. So if you, Mickey, if you want to have a look, you can go to that website. So it's World Bank Data Catalog. You can download. So it's global level data set. So maybe it's important to mention here that you have different level of hazard data, and the global one is obviously the one that at the bank we are working on and trying to support. It gives you already a good level of information, but of course, if your country is providing more detailed level of information, it's also good to check. So I may also encourage you to see or ask as let's say organizations in your country working on hazards, and is there any research that has been done and that's tried to produce data on slides, something that you may want also to look at, and then you can overlay with the data, for instance, from OpenStreetMap to see and to try to see exactly where are the risks of that type of hazards. I see we have another question, maybe from Tinto. Tinto? Yeah, you can go ahead. English or French? Fortunately, we can't hear you. Let me try to, or you can type your question in the chat room.
Can you hear me?
Yeah, we can.
Yeah, it's better now. Okay, thank you. It's my earphones. I was saying thanks to Pierre, Grace, and all your colleagues for this opportunity. I don't really have a question. If I have a question, it is to know if droughts can be considered like a disaster or something you consider in your scope, and related to what is happening here. I'm from Burkina Faso. I'm living in Ouagadougou, the capital city. And most of the situation we are facing in the big cities. Sorry, there is a bit noise.
Go ahead. We can hear you.
Yeah, most of the things we are facing is floods in the bigger cities, but it seems like it's not related to directly to climate change or something like that, but it's most related to the fact that the urbanization does not take into account that aspect of allowing the flows of the water when it's rain.
Mm-hmm.
So yeah, of course, when it's rain and people are building their houses near the space the water used to flow,
Mm-hmm.
naturally there is a lot of floods. But another things I said is about drugs that we are experiencing, and is a cause of nutrition problem, because in the country, when there is not enough rain in some villages, cities, the people are not they are living, most of them, by agriculture. If there is no rain, they are not able to grow something, and it ends by starvation and so on. So I'm interested to know if you are working to support on trying to have data on droughts, vulnerability on droughts, and how these data can be used to have some kind of resilience from citizens living in villages.
Yeah.
Thank you.
Yeah, thanks a lot, Tinto. I mean, drought is definitely part of the let's say the catalog of disasters hazards, and one that is particularly acute, well, in your country, but also in the whole Sahel region. In the whole Sahel region, you have both drought, but also floods, and so it's I mean, a very difficult combination of hazards to manage. So yes, it's part of the type of let's say hazards that are tackled. So it's kind of hazard that is difficult also to predict because of as you know of the climate change situation and projection and so on. But definitely one that I mean, researchers and people in development organizations are looking at a very acutely. And for instance, World Food Program, people from the OCHA, which is the Organization for Humanitarian, they have they are tracking that type of disasters, and to make sure that they can respond quite rapidly. But something I wanted to say as well is actually when we start speaking about disasters, we'll very rapidly we start about the intrication in the combination of different disasters. For instance, currently we all lay in kind of a disaster with the COVID pandemic, which is adding on the burden of other disasters in some part of the country. So you also have to take that into account and to understand, I mean, how to prepare or how to respond to a disaster when you have such a combination. Something I wanted to say as well, and so I saw some questions on and remarks on from Lindsay on the situation also in the US. so what you can do at your level, even though you're not a disaster risk expert, even though you're not working in an organization like GFDRR, for instance. I think first of all it's important for you to be aware. It's important for you to be able to share the right information. There are also lots of issues regarding misinformation. So to be able to point the people to the right resources, to the right sources of information. And for that, obviously, open data in open access to information is key. But it's also important for you to take governance to account. And for instance, to look at what they have done to prepare for a disaster. For instance, in Burkina Faso, in Ouagadougou, what are they doing to prevent for the next flood, for the impact of the next flood? So this is important to look at that type of programs. And if there is one program, for instance, of flood mitigation, let's say in Ouagadougou, to make sure that they will do things right. So as you said, Tinto, the issue is not so much about the fact that there is a lot of rainfall, but the fact that there is what we call urbanization, uncontrolled urbanization, and the fact that let's say the basic infrastructures are maybe missing. So this is a kind also of interactions that we want to see to happen. And when we say at the start of the presentation that you can also have a role to play, it's as a citizen, as an NGO, but also as people who are working on that type of information, you also have a role to play. Yeah, that's just what I wanted to echo. Yeah, actually, yes, we have done some work on Burkina Faso. So it's almost, I mean, it's already the end of the session. I think we are going to stop right now, but I will just get back to the slide. I'm going to put the slides on my Twitter account. We are going also to put on our blog. Yeah, go ahead, Grace.
Yes, so the slides, we'll be posting these slides on the same webpage that you found the event on OpenDRI.com. So you can access each of these links there on the right. We have, I'm not sure what other notebooks, Matt, you may know if we have any other Python notebooks that are available publicly, or if this is the only one we have opened right now.
Yeah, this is just a demo, and this is something we are working on together with the platform and infrastructure that will allow us to offer the data to use in the notebook. So it's something that will be developed later this year and next.
But we do encourage you. We have our team email at the bottom of this slide. Oh, I think, Pierre, could you actually exit out of full screen? Yeah. Okay. So it's OpenDRI@gfdrr.org. A great acronym, a set of acronyms to memorize. But yes, it was wonderful to be able to speak with everyone. I also wanted to say thank you to Misha, who's not on the call, but who set up the this Zoom call for us, as well as Arthur, who is on the call in the French room right now. Probably still interpreting. Thank you so much, Arthur, for doing this as a single interpreter for this entire event.
And thanks to you, Grace. And please do contact us. So if you are aware of any project in your city or in your country, and if you think there is something that could be done on disaster risk, and you think there is not enough open data, please do contact us. And thanks again for joining.
Thanks, everyone. Have a great weekend.
Thank you, everybody. Bye.